Hello everyone. Hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today, we will go through the core concepts of database management system and SQL query for data integration. So, GIS database stores and manages spatial and attribute data systematically, where we have to organize, retrieve, and manage geospatial data efficiently. It uses database management system for data storage, querying, and manipulation. The characteristics behind that procedure related to the data is data integrity, data security, and multi-user access. So in civil engineering domain, the data is used in urban planning databases and infrastructure management, which supports large scale engineering data handling. Database management system, which is a critical intersection of technology where the integration of data or the management procedure or management systems with geographic information system working together. In the world of civil engineering, we are moving away from isolated CAD files and towards integrated data environments. So here we will discuss a robust DBMS acts as an engine for a GIS, allowing us to manage vast amounts of infrastructure data with spatial intelligence. It integrates the transformation, a simple digital map into a powerful decision support for smart cities and large-scale construction projects. So the hybrid architecture for spatial and spatial data, which is bridging the gap between coordinate geometry and descriptive data. So spatial entity where dependent on positioning, we can ask where so that we get the position. That is the coordinates, which is a spatial entity. But a spatial attribute, which is a tabulated format where assign ID, assign nomenclature, assign characteristics, assign parameters are listed in a table where what we have to be asked so that the detailed report or detailed information we can check or we can collect. Likewise, the vector data is a spatial attribute data and the raster data is a spatial entity data. Moving towards the relational model. Now, why relational model is most important in the database management system? Because if we are comparing the data in a table, then there are n number of rows and n number of columns. Column have some parameters and rows have the list. So with respect to that, we have to maintain the relation based on the table, the attribute which is in the column which shows the degree and tuple which shown in the rows or it itself shows the record. Now we have to relate that attribute with respect to tuple based on some row to column, n number of row to a single column or a single row to n number of column. So that relational role of database management system, which is most important for analysis. So the relational database management system, most common model for GIS integration. It organizes data into tables that are linked by keys. For example, a pipe table can be linked to a material table using a unique ID. Means we can compare the table or we can compare the table of pipe data which will be linked to the material which is used for manufacturing that pipe by using some unique IDs. Just like the marks of any student and the rank of that student based on that mark, which will be compared on the basis of ID assigned to a respective student. So, in civil engineering, this relational structure is essential for asset management or in town planning department. It allows us to manage millions of infrastructural components without duplicating data, ensuring that every value, manhole, and road segment is accurately represented and easily searchable within the broader citywide GIS domain. SQL queries in GIS. What do you mean by SQL? Structured query language. So structured query language, which is a method where we can ask the queries in the existing data in the structured format or in the regular format. With respect to that queries, geographical information system update the existing data by the based on the data in terms of rows or in terms of column or in terms of keys or in terms of links or any relation. So the structured query language interrogation in GIS are used in GIS to retrieve, filter, analyze the spatial and attribute data efficiently for engineering applications. Main operation for the structural query language is that we can select the filtering records, project for displaying the required columns, and join the linking related database tables. So we can select the row, we can project the column, and we can link both the rows and column within a single table or within n number of tables. In civil engineering applications, structured query language, which is based on GIS analysis, supports in land use planning, urban development, transportation studies, environmental analysis, and infrastructural management in remote sensing and GIS projects. We can compare each and every data to update that existing data by using some query, by using some structured query language or application. And with respect to that, we can update the raster data or we can update the vector data. So rows and columns means the vector data is linked with respect to the relational model which is available in the tabulated format. And collecting the data, so we require some space to store that data if that data is in terms of raster or in terms of vector likewise. So the physics behind that data storage where raster calculation is there. If raster data is there, then we can take the elevation also. So y rows, x columns, and z depth in bit or in bytes. So storage is equal to rows into columns into bytes. Means what much amount of data is stored. Okay, so raster data structure is the raster data in GIS which is stored as a grid cells arranged in rows and columns where each cell contains geographic or image information. Raster storage depends on formula. Storage is equal to rows into columns into bytes where higher resolution and a bit depth increase file size and processing requirements. Civil engineering domain use raster calculations in remote sensing and GIS for flood mapping, terrain analysis, land use studies, watershed management, and infrastructural planning. Now, we are studying the optimization, which is a spatial indexing. Optimization of data by spatial indexing. So, spatial indexing, which is most important point where we have to check the actual ground control points or positions with respect to the directions. So Quadtree spatial indexing divide geographic space into smaller regions, just like northwest, northeast, southwest, southeast, etc. So to organize the spatial data efficiently, that indexing is most preferable. In remote sensing and GIS, this improves storage and searching of satellite images and maps. Civil engineers use it for land use mapping, terrain analysis, and infrastructural planning. The tree structure shown on the slide stores that spatial information from the root to smaller subdivisions. Areas with more data are divided further, enabling faster access to required information. That dividation, which helps GIS system quickly process the large data sets used in transportation, drainage, urban planning projects. So spatial indexing supports remote sensing image processing, disaster management, smart city development, tools used for each and every domain in civil engineering projects. It reduces the computation time and improves the accuracy of GIS analysis. Civil engineering applications includes road network analysis, flood modeling, utility mapping, and environmental monitoring by using that spatial indexing. So the importance of spatial indexing for data retrieval is most important. That data retrieval is used again and again for the updation of existing structure based on some routes. There is the velocity, where speed of data retrieval. Slide or the data which is incorporated in that slide, which is a graphical representation where data volume in number of records on x-axis and time to retrieve on y-axis, where the orange line is the sequential search, which is a more tedious process, while the blue line, which is the index search, which is the most efficient one. So without indexing, search time increases linearly with data size. As data size increases, search time increases. So with indexing, it remains near instant. Means that indexing is most important point to maintain the velocity of data retrieval, which increases with data volume in GIS system. Sequential search becomes slower because every record must be checked individually. Index search keeps retrieval fast and efficient even for large remote sensing datasets also. So the red graph or the orange graph represents sequential search with increasing search time, while the blue graph represents the index search with near constant speed. Spatial indexing techniques helps GIS system quickly locate geographic information. This improves performance in civil engineering, mapping and analysis of tasks or any problem. Index data retrieval is useful for satellite image processing, urban planning, flood monitoring, infrastructural management. It reduces computational time and increase efficiency in handling the large datasets or spatial datasets. This makes GIS operations faster, more accurate, more reliable for civil engineering projects. Third part is the defense or in terms of the security. So data integrity, which is the most important phenomenon where the user input is a multispectral, or we can say the user input is in n number of domain. So we have to use that input. We have to arrange that input in the structured way. We have to use that input by using some filtration, by using some analysis, by using some comparative techniques where valid storage is only used. Enforcing constraints to prevent data corruption means we have to provide the safety to the data. So the data integrity protects GIS datasets from incorrect or corrupted information. In remote sensing and GIS, large spatial datasets require accurate and reliable input data. Validation rules help ensures that only correct geographic and attribute information is stored. This improves the quality and consistency of civil engineering datasets. So we have to improve the quality of datasets by minimizing the incorrected data or corrupted information. For that purpose, we have to use the filtering and validation procedure where the funnel diagram is there, which represents the data filter that checks user input before storage. Range checks, type checks, and mandatory field validation remove invalid and incomplete records. In GIS applications, this prevents errors in coordinates, spatial attributes, and survey data. Such validation improves the accuracy of mapping and spatial analysis. So data integrity is the important for infrastructural planning, land surveying, flood mapping, environmental monitoring. as we have the valid storage based on that enforcing constraints. Accurate GIS dataset supports better decision-making procedure and reduce the risk of project errors. Remote sensing system also replay or also rely on validated data for image classification and spatial analysis. So the overall data integrity, which provides the safety, which ensures the reliability, security, and efficient geospatial management to the data. At the end, the efficiency, if we have efficiency, then our data is most accurate. So for that purpose, we have to eliminate the redundancy. Eliminating the redundancy from the data, where the redundant data increases the storage usage. Redundant data increases the storage usage and creates duplication in GIS datasets. Means where before the table is there, parcel ID, address, owner name, owner phone, owner email. So the n number of columns are there for a single parcel ID. But if we normalize that data by using column number 3, owner name, and column number 4, owner phone, we have to normalize that data with respect to the two tables, where table 1 is a parcel and table 2 is the owner. Means column number 3 and 4 comparatively relate with respect to the owner ID for that parcel ID. Means parcel ID, address, and owner ID. That owner ID have displayed with respect to the table number 2, which is of owners. Then that owner name, owner phone, and owner email. Likewise, the whole primary key is used for the replacement or for the representation of data, so that we can minimize the redundancy or we can minimize the obstacles in between the data. So this technique may increase the efficiency of the data model. So in the before table, the same owner information is repeatedly stored for multiple parcel records. This repetition can cause inconsistencies and inefficient data set or inefficient database management. In remote sensing and GIS, reducing the redundancy improves data organization and system performance. The after, which is a normalized data section, where parcel data and the owner details are separated into different tables using common owner ID. This method stores repeated information only once and links related records efficiently. So the normalization improves that the database accuracy, then reduces storage requirements, simplifies updates, etc. So it helps to manage the large spatial and attribute datasets effectively. Normalized datasets are important for land record department, land record management, cadastral mapping, urban planning, and infrastructural monitoring in civil engineering domain. Civil engineer use the GIS datasets to manage parcels, utilities, transportation networks, survey records efficiently. Reduces redundancy or reduction in redundancy improves the query speed, data consistency, and decision making accuracy. Means the efficiency is dependent on the velocity, which is dependent on the data security, which is also dependent on the data retrieval or indexing. Means these three components integrates the efficiency of any data, which makes the GIS operations more reliable and scalable for large engineering projects. So data integration, which is the most important point, based on this spatial indexing of that data, velocity or speed of data retrieval, then data required or the storage required for data, and then efficiency, where eliminating the redundancy is most important. Now, what are the applications in the land records management? Just like the cadastral survey, cadastral systems rely on the precise integration of geometry and legal attributes. So by using the layout, we can select any type of layout and with with respect to that layout, we can zoom in with respect to some ID or with respect to some attribute data for any location or for any ground control point, where parcel ID is 89A, which is the nomenclature given. Owner is the state government, means that ground control points are in the premises of state government, where area 4.5 acres, deed date is there, and survey precision is there. Means we can use that data for the data integration and scalability. Moving towards the database management system or the geographical information system ecosystem. Why that whole cycle is there? Because this is a cyclic process and continuous process from the input up to the decision making process, then again input. So components of an integrated system are the three primary components: the spatial data store, attribute database, interface layer. The spatial data store manages coordinates and topology, while the attribute database handles text and numerical data using relational database principles. The interface layer, often powered by structured query language, allows users to query both type of data simultaneously. In civil engineering management, this means you can perform complex queries like show me all reinforced concrete columns that are located in high seismic zones, or any type of like questions or queries we can generate, so that the decision making procedure must be more reliable. Why do we need to integrate the database management with respect to the GIS? Traditionally, spatial data and attribute data were stored separately, which led to inconsistencies and data redundancy. So, for civil engineer point of view, having the location of a bridge in one file and its maintenance history in another one is inefficient and prone to error. So comparison in between that two files must be hectic. So integration of data allows us to store geometry and descriptive parts or attributes in a single unified database, which ensures that when you update a record, such that the condition of water main, such that the actual ground conditions, ground points, information related to that points, which will be immediately available for special analysis across the entire project team, which more useful for decision making procedure, so that the integrated database is more effective. So transforming the raw data into the spatial data, transforming the raster data into the spatial intelligence data with respect to some queries. So that queries must be structured and most important for the decision making procedure. Stay tuned, guys. Happy learning.